Hello, folks. So, a few videos back, we created this RPG character in JavaScript, and we have implemented the movements, and we have also implemented the diagonal movement. Now, I have removed the code for the purpose of this video because today we want to implement a grid system. Because right now, our player is allowed to move in any pixel, but in some of the RPG games like Pokemon, there is a strict grid system. So, our player is only allowed to move in specific grids. They are not allowed to move in any pixel. So today we will see how we can implement that. So let's get back to our VS Code and let's take a look at our code. So we have many things defined. We have a player image, which is a sprite sheet. But the most important thing to look at is our object called player. And the player has an X and a Y value, which is the pixel value, has some speed, has some frame X and Y, which corresponds to our sprite sheet, and also many, many more things. Now we have this X and Y, and whenever we are pressing keys, so WSAD, we have an update player function, and there we are changing the values of our X and Y directly, and hence we can move to any pixel. This is something we need to change now. So to create a grid, we need to create some more variables. So first of all, I will create something called a tile size. Let's say it is 80. And then we need to create our grid width and height. So grid width. So this is the total width of our grids. So I'll do a match.floor canvas.width divided by tile size. So we have tile size as 80, canvas.width is 500, so it is 6.25, mat.floor is 6. So we have like 6 columns for our grids. Now 480 value would have been better, then there would not be any need of the mat.floor, but yeah, anyway, this will work also. We will also define a grid height. This will be mostly similar. So match.floor canvas.height divided by the tile size. Now, after defining the grids, we need to add few more things to our player also. So now we have a value of x and y. This is something we want to change. Instead of that, we want to have a grid x and a grid y. So what is a grid x? So grid x is basically what is the current grid our player is starting at. So if we see the x value, it is starting at the midpoint of the screen. So we also want the midpoint of the grid. So we'll do a match.floor grid width by 2. So if we have 6 grids, this is 3. And similarly, the grid y will also be match.floor, the grid height by 2. Now after the grid x and grid y, we need a target grid x and target grid y. This is required for our movements. So now we have a grid x, which is at the midpoint, and our direction is idle. So the next target grid will also be the same grid. So here we'll write the same thing, but when we are moving, this will be changing. So grid width by 2, and also same for the height. So this is the grid y, and we'll do a grid height by 2. Now this is for the grids, but when we are drawing the player, we actually need pixels. So exact pixels. So for example, x and y, and these are exact pixels. So somewhere in the hundreds. This is in the 1 to 3 range. So we'll create two more variables called pixel x. So what is a pixel x? Pixel x is actually very simple. Match.floor canvas width by 2. This is the grid number. We will multiply it with the tile size. That's all. And the pixel y is also mostly similar. So pixel y will be canvas dot height uh, divided by 2 times the tile size. Now we can remove the x and y, but we can also keep it. Really doesn't matter. So let's keep it for now. Later we'll see what we can do with it. Also one more thing. Instead of the speed of 3, I want to change it to 4 because we have the grid size as tile size as 80, and 4 would be better because 4 is divisible by 80. I mean vice versa. So anyway, so this is something that we have done already. Now if we take a look at our player, nothing will change because we have only defined some variables. So what we want to do now is also want to draw our grid. So below we have a game loop. We are doing an update player and a draw player. Now in our draw player, we are simply drawing our player using the draw image. And here, after doing the draw player, we also want to draw the grid. We may not do this also, That is perfectly fine. But yeah, for better clarity, I will say we want to draw a grid also. And also in our draw player, there are a few things that needs to be changed. And here we are setting our x and y values. So instead of x and y, we want to set the pixel x and pixel y because this is something that we will be working with right now. So pixel x and pixel y. Now, when it comes to draw grid, we want to write a function called draw grid. And draw grid is basically nothing but drawing the row lines and the column lines. So what we will do is we'll define a stroke style. Let me give gray for now. And also let me give a line width of 1. Now we'll create a for loop. So the for loop, let it start from x equals to 0. Let it loop till canvas dot width and let it add by so plus equals to tile size. Now inside what we want to do is ctx dot begin path. We want to draw lines. So we will first of all move to the top of the screen. So ctx dot move to will move to x comma 0 and then we'll draw a line till the bottom. So x comma canvas dot height and then we'll do a ctx dot stroke. Now after this one we will need another loop. So this will draw the column line. So we want to draw the row lines. So this will loop till the canvas dot height. We will take the 0 comma y and we'll draw up to canvas dot width comma y. And if we take a look now, there are some errors. So let's see what are the errors. So ctx dot line cap is not a function. Ctx dot line cap. So here we have done a line cap. So this will be a line 2, not a line cap. And uh, our player is missing now. And so why is our player missing? Um, we need to check that why our player is missing. But if we simply change it back to x and y, I believe our player will come back. Yes, our player came back, and but our player is starting somewhere the grid is crisscrossing. So ideally, our player should start at a grid. So anyway, this is something we will change later. So the pixel x and y is not properly handled. So that is why we have this weird behavior. So we have drawn our player and our grids. That's fine. We'll come back here later. Now we have our update layer where we are changing our values. And this is where the fun begins. So we need to do a lot of changes inside our update layer. So first things first, we need to check a few things. And that is if the player.pixelx, this is not equals to our player.target grid x times our tile size, or the player.pixel y is not equals to player.target grid y times the tile size. If this is the case, then we need to like handle our player. So what we have written over here is if the absolute value of the pixel is not equals to the grid value of the pixel. If that is the case, then we want to move our player. So why we are writing this? Because whenever we are pressing some buttons, so our player will ideally be in a grid position. But when we are moving the player, for a while the player pixel value will change with respect to the grid value. So in those cases, we have to animate our player. So this is why we are doing this. And in that case, our player dot moving will become true. So initially it is false. We have it here. But in this case, our player dot moving becomes true. And let's see what more things we need to check here. So we'll check if player dot our pixel x, if this value is less than the player dot target grid x times the tile size. If this is the case, then we need to set a value of the player dot pixel x. And this value will be the minimum of the two values that I'm writing right now. So this will be player.pixelx plus the player.speed, which is 4. The minimum value of this, or the player.targetGridX times the tile size. Now, what does it mean? It means that, so let's say whenever we are moving up, like whenever we are in the up or down direction, so this is the grid value of our player. So this value will be set at our boxes. However, the above value where we are changing by player.speed, this value can be in between. So this value can be 84, 88, like that, but this value will be in multiples of 80. So we will take the minimum value of these two, and this will be our player.pixelx. Now, why we are taking this? Uh, we are taking this to appropriately reflect our movements and our position. So this will be clear in a while. So let's write the 4 cases for this one. So this is one case, and else if we'll check the other case, if the player dot pixel x, if this is let's say less than, so we are checking the pixel x. So now, so first of all, we are checking if it is less than the player dot target grid x. So let's say if this is greater than player dot target grid x times the tile size. This is player dot. There is nothing called the target grid x on its own. Now in this case, the player dot pixel x, this will be equals to again our match dot maximum this time, because the direction has changed, and the match dot max of what? Match dot max of mostly the same things. So player dot pixel x, instead of plus, this will be minus, and the player dot target grid x times our tile size. So this is one case. Now we need to check the same for our y values also. So player dot pixel y, if this value is less than the player dot target grid y times the tile size. If this is the case, then player dot pixel y, this will be what? This will be maths dot min of our player dot pixel y plus our player dot speed, very similar to the x, and also we'll check the player dot target grid y times our tile size. Now for the else case, else if we need to check if the player dot pixel y is greater than the player dot target grid y times the tile size. In this case, we will differently handle it. There looks like some sort of an issue here, and the issue is this. This should be maths dot min of what? Yes. I think there is a missing bracket, and that is the issue here. So here we'll close the bracket. So this will close here, and this will close here. Yes, now this is good. So player dot pixel y, um, this will be equal to maths dot max of uh, something similar. Direction has changed, so minus player dot speed. So this is the situation that we have right now. So there is some sort of like a syntax issue. So in line number 129, and there is an extra bracket. So now if we check once again, we have our player, well and good. Now a player is not starting like spawning in the appropriate position. So we'll check this one. Uh, but yeah, so this is how we are checking our checking and assigning our pixel x and y values. Now, after doing this, we need to do one more thing, and that is, so we have target grid x and y, and all of these things are changing. All of that is fine. After doing this, we need to check if the absolute value of our player dot pixel x minus the player dot target grid x times the tile size, if this value is less than our player speed. So if this is less than our player speed, Now this is one case. So again, we have issues, I think. Now it's resolved. Now this is one case, and another case is the same for our y direction. So this is checking the x, and for our y, mm, we'll check if this value is less than our player dot speed. Now instead of pixel x, we'll do a pixel y and target grid y times the tile size or whatever. Now in this situation, what we need to do? So we'll assign the value of pixel x to be the player dot target grid x times the tile size, and for the pixel y, the target grid y times the tile size. Now this should be clear what we are doing here, right? So what we are doing here is simply um, we are checking if the math dot absolute value of the player dot pixel x minus the this tile size times our grid x, if this is less than player speed. So what this means is this is a multiple of 80, and the player dot pixel x can be anything, 84, 88, whatever. So if somehow a situation comes that the difference is less than the value of player dot speed, which is 4. Now that is not a situation that we want. We want the players to be fixed at the grid locations. So the pixel x and pixel y should be fixed to the target grid x times tile size, and for the y also. So in those situations, we want to set it like this. So that is exactly what we are doing now. There is an issue. The math.abs value should be assigned twice. So here there will be a math.abs. This will should be removed, and it will come over here. Ah, so this is what we want. And after this, we also want to change the current value of the player grid. So we are taking into account the target grid x. So the grid x should become the player dot target grid x, and so for the y. Now all of this may seem a little bit confusing right now because we are doing a lot, but soon enough we will have a smooth grid movement. So yeah, so we are assigning the pixel x and pixel y like this. So all of that is fine. Now what we need to do is, let's say we have these situations where we are setting our pixel x and pixel y values in certain situations when these values are not equal or whatever. Now, in the else case, we actually need to do our movements. So we have our if. Now here in the else, what we want to do is we want to do all of these things. So here what we are doing is we are changing the values um, of y, x, and y with the player speed. Now, in our case, we are already doing it at the top. So, whenever we have certain conditions met, we are changing the value of pixel x and pixel y. So here we don't need to change that. But what we will change is whenever we are pressing W, our target grid is actually changing by 1 pixel. So not 1 pixel, I mean by 1 grid. So the target grid y in this case will become the player dot grid y -1. And in this case, and the direction will be walk up. We don't need to assign the player dot moving to true. I believe it's already done at the top. But yeah, even if we are assigning it's not a big deal actually. So okay, so this is fine. Now here we will take this one. We'll remove this one. So whenever we are pressing S, the grid will become +1. Now for our X, whenever we are pressing A, the player dot target grid X will be player dot grid X -1, and for this case this will be +1. And we will also have an else case, so where the direction will be idle and the rest of the things will be as it is. Now after having all of these things, we can now change it to player.pixel x and the player.pixel y, and same here. pixel X and the pixel Y. Yes. So let's take a look at what we are doing right now. In our update player, we are first of all checking that the player.pixel X and the player.tile the we are checking the pixel position and the grid position are not equal. If they are not equal, the player is definitely moving. Now there are four cases of moving. That is the four conditions that we have, and accordingly we are changing the value of our pixel X, and we are also checking if this is same, like same, greater or lower than the value of our target, like our grid pixel value, and we are accordingly setting the value of our pixels. Now after doing all of these things, we are again checking if this is somehow less than the player dot speed, the absolute value, and then accordingly we are setting the value of our pixel X and Y to our tile size. Now this is for the case of our movements, and otherwise, in the otherwise case, we are pressing our buttons and we are moving. So whenever we are pressing a button, our player moves. But when the movement is happening, this above else case is triggering for changing our movements and everything. So we are changing the directions accordingly, and yeah, so this is what we have right now. And lastly, we are drawing our player with our pixel X and Y. So let's see what we have now. So we don't even have our player. So there is some issue. Let's try to find out what the issue is right now. So the first issue is there are some typos here. So in the Pixel X, we are actually dividing canvas width by 2. And this should actually be grid width by 2 rather than canvas width. Because canvas width is 500, whereas grid width is only 6. And this will be grid height by 2. So there is a silly mistake here and another typo kind of silly mistake here. So here what we need to do is we need to do a player.pixel y minus target grid y times the tile size. The bracket was incorrectly placed. And this was our typos. And now if we check, it will still not work. We have our player, and as we can see, the left and right is working fine. The down is also working fine. But there is an issue. If you press up, something weird happens. So this is a weird behavior, and why is that? And this is not a typo actually. So whenever we are pressing our keys, we are also still checking our player X and Y, which we are no longer using. So there are a few missing things here. So what we need to check here is the player.gridY should be greater than 0 for this case. When we are pressing X, the player.gridY should be less than, not the canvas height, it should be less than the grid height minus 1. Similarly here, instead of an X, it should be player.gridX should be greater than 0. And so we are subtracting grid X by minus 1. And here it should be less than, not the canvas width or whatever, it should be less than grid width minus 1. Now our grid movement will be absolutely fine. And hence we have a beautiful character movement for our RPG game. Now if all of this code is too much for you, I will link my GitHub repo in the description below, so you can just take the code from there. And from now on, we will make a lot more things about RPG games also, like scene change, dialogues, etc. etc. And so that's it for this video, folks. And if you have learned something new, make sure to like, share, and subscribe. It helps me grow the channel fast. And I will see you soon with another very interesting video. So see ya.